Next and third talk is by Erica Fleischman with Oregon State University, who's going to talk about the consequences of all this for disturbances in the sagebrush biome.
Great, thank you. All right, can people see my screen all right? Looks like a couple nods, so I'll assume that is a yes. Thank you for the opportunity to talk with all of you today. I wish we were doing this in person. It is super fun for me to be able to talk about these ecosystems. I have worked in the Great Basin, especially the Central and Western Great Basin, since the early 1990s. I love these ecosystems. For the past 4 years, I've lived in Western Oregon, where there is a lot of precipitation. It is beautiful and it is weird. I keep seeing these big trees and I think that they're hundreds of years old. And then I say that to someone and they look at me and they say, no, that tree is 40 years old, and it's very strange. Anyway, so it is a pleasure to talk with all of you. And what I will try to do is to build on some of the points that previous speakers made, and to the best of my ability, address a couple of the questions that have come up in the discussions. Wouldn't it be nice if the world would adapt to us, but it doesn't work that way. So this is why we have events like we do today. I was asked to talk about a couple different, how some of these changes in climate may affect disturbances, and obviously a big one is wildfires. Aridity means that wildfires are a lot more likely. When you have drier dead plants, when you have drier living plants, they burn more easily, they carry fire more easily, they ignite more easily. And especially in forests, which I recognize are tree dominated, not sagebrush dominated, but a lot of people tend to my great disappointment, look at wildfire and forest fire as synonymous. It is something that many of us, I think, are trying to correct on a regular basis. Nevertheless, there's been a fair bit of work that has associated measures of vegetation dryness with area burned in the Western United States. So this is a well-established relation. The physical and biological reasons are well understood, and the observations are consistent with the scientific logic on all of this. What is contributing to aridity? Some of this has already been addressed. So the United States is warming faster than some other regions of the world. The Western United States is warming faster than some other regions of the United States. And summer temperatures, in a relative sense, are increasing more than wintertime temperatures. So both averages and extremes are increasing. The magnitude of extremes is generally, the magnitude of increase in the extreme temperatures generally is consistent with the magnitude of increase in average temperatures, and the greatest increases are during summer again. Okay, so high temperatures are contributing to that aridity. You've already seen some of this. So with respect to wildfire, we know that daytime temperatures and nighttime temperatures are increasing. Nights are increasing in a relative sense. Night temperatures are increasing more than daytime temperatures. That will continue to happen. And that has somewhat greater consequences for wildfires. Sort of in the vernacular, it used to be more common for wildfires in the West to kind of lay down at night for temperatures to drop and for humidity to increase. And it used to be easier to get, if a wildfire, if it was decided that a wildfire would be suppressed, it used to be easier to get a better handle on that wildfire overnight, not so much anymore. I am also going to make one point on years. When you are looking through the National Climate Assessment or regional climate assessments or what have you, for various reasons, the baseline periods of warming tend to vary, those reference periods. So for example, in these cases, relative to the second half of the 19th century, that doesn't change the trends. It's getting warmer no matter what. But just keep your eye on what are those baselines, because they often are different, and they often are different in the same document. And that is not because anyone is trying to pull a fast one, but just recognize that it can be a little bit apples and oranges with respect to reference periods. There's been some discussion about precipitation and aridity, and especially in the last presentation, that precipitation does not equal aridity, does not equal drought. Because people have talked about things already, I can digress a little bit. So there are a number of projections that suggest that absolute precipitation received in the Western United States is likely to increase. Precipitation, that doesn't mean that doesn't mean that there's not going to be more drought. The precipitation projections vary a little bit between statistical downscales and dynamical downscales. So if one compares some of the projections of global climate models to observations on the ground, there generally is less of a projection that precipitation will increase, especially on the east sides of major mountain ranges in the West. Dynamical downscales, which work with basically higher resolution climate models, suggest some increases in precipitation in, for example, Eastern Oregon, on the east side of the Sierra Nevada and extending further out into the Great Basin. They tend to suggest more precipitation in the shoulder seasons, especially. So it varies a bit from model to model. One of the constraints, and you could see one of the constraints in all of these projections, and you could see this in those red and blue circles that we were just talking about, is that there are darn few actual observation stations across most of the Intermountain West. So if you look at any maps of observations and you look at where the observations are made, you tend to see lots and lots of observations in places where lots and lots of people live. You don't have a whole lot of weather stations across Eastern Oregon, across most of Nevada, across much of Utah, what have you. And so that also constrains the ability to make reliable projections because so many of the projections rely in one respect or another on historical observations. So there may be an increase in absolute precipitation, but again, more precipitation coming as rain than as snow, especially at lower elevations. And because it's hotter, that precipitation is likely to, in effect, water availability is likely to still decrease. Okay, back to wildfire. Some of the things that have been in common in some of the wildfires in recent years that have been extraordinarily damaging to people and property. So if we think about the Marshall Fire near Boulder, the wildfires in Hawaii this past summer that pretty much wiped out Lahaina, and most recently the wildfires in Texas. A couple of things in common. None of them were in forests. They were all in areas that were dominated by grasses, shrubs, what have you, all in areas where there were fairly high densities of non-native invasive grasses, and all of them, to a large extent, were wind-driven. So you have these wind-driven wildfires, and that means a couple of things in respect to potential management decisions. So there is a lot of discussion across the West about vegetation removal. Often the reference is to fuels. I always like to remember that another name for fuels is plants. So we think about plants in different ways. Vegetation removal, generally speaking, is not effective for wind-driven wildfires. There were a number of wildfires that many of you probably have experience with where they were wind-driven and sparks were traveling across the Columbia River. I had an idea of how big that was in my head, and then when I saw it, the river for the first time, thought, that is an incredibly large river. I mean, so basically you have sparks. If you have a wind-driven wildfire, the sparks are going to jump a little strip that you mow in the middle of sagebrush. The sparks are going to jump lots of trees. If you have a wind-driven wildfire, all of the time and money you spend on vegetation removal is not going to be effective for that particular fire. May be effective for reducing sort of fire speed and intensity in some ecosystems under some conditions, but keeping in mind that the vegetation grows back and needs to be maintained. The other thing, when I look at images like this, or when I'm in places like this, is we know across sagebrush ecosystems that cheatgrass and other non-native invasive plants love ground disturbance. So when I see something like this and am told, oh, we're removing trees because of wildfire risk, I think about, but you are also creating conditions in which cheatgrass and other non-native invasive plants may have a party if you are not doing a whole lot to try to reduce their spread in those areas. So lots of trade-offs, and many of these wildfires, again, being driven by or being sustained by dominance of non-native invasive grasses. There have been some projections, Bethany Bradley's group in particular, this is work done a couple of years ago now, that as climate across the Intermountain West changes, there may be some areas that become inhospitable to cheatgrass. On the one hand, great news. On the other hand, pretty difficult to reestablish natives in areas that have become cheatgrass monocultures. So some of us start thinking, okay, so if cheatgrass dies, does this mean we have large areas of bare soils and we're going to have a lot more dust and a lot more erosion? So, pick your poison in some of these respects, but difficult to project exactly what some of those changes might be. Okay, what are other things to think about with respect to climate change and wildfires? One is what is igniting the wildfires and where people can do something about that. So I pulled these data from the Fire Program Analysis Fire Occurrence Database, which is archived with the Forest Service Research Data Archive, which is a tremendous resource. So on the y-axis, you have number of wildfires, years on the x-axis. And I pulled these data for the level 3 ecoregion, Central Basin and Range. So way more human-caused ignitions than natural ignitions. Natural largely being lightning. So this is a potential opportunity. We can then break down what are the causes of human-ignited wildfires in the Great Basin across the past 10 years or so. A lot of equipment and vehicle use, and you can see sort of the range of causes. So this can suggest, in some cases, there's not a whole lot we're going to be able to do about railroads, but in some cases suggesting recreational or other uses where there may be some opportunities to reduce the number of ignitions. We can't necessarily change the fire weather conditions, but we can try to change human behavior if we so choose. Wildfire sizes, very few arson fires, but in the Great Basin, they've been large. This is somewhat of a sample size, not problem, but sample size effect. Many of the lightning-driven wildfires have been larger. So lots and lots of things that one can do with these data. This database has been enhanced by a terrific group at Boise State University. So basically, you can look at lots and lots of fire metrics across the United States, including those in sagebrush-dominated ecosystems. Also, what you'll see across much of the West, and I think many of you are aware of this, is you tend to see a spike, especially in fireworks-caused wildfires, oddly enough, right around the 4th of July. So it can be kind of interesting to look at some of the temporal trends as well as the spatial trends and get a sense again of human behavior and where there are opportunities to modify human behavior to reduce some of the wildfire risk. Public health, obviously, and this has come up with compounded effects. Wildfires and other aspects of climate change very strongly affect physical and mental health of all age groups, and that carries over into what people are dealing with on public lands. Many more people are affected by smoke than they are by the flames. I'm not saying that it is trivial if one loses property, livelihood, what have you, from the flames, but in general, over time, there are expected to be more days with wildfire smoke, and even more than that, a higher concentration of fine particulate matter on those days with smoke. So that affects people regardless of where they live. But if we're thinking about people who are recreating on public lands, this is going to affect their experiences. Or if we think about closures of public lands because of fire danger or actual fires of smoke or what have you, also changing those disturbances. And again, the warm nights come into play because in terms of human health, warm nights are more dangerous than warm days. People are used to passive cooling, especially when they're recreating and camping. Then if we think about what are some of the carryover effects to wildlife that people that are sort of a focus of recreation in much of the Intermountain West and sagebrush-dominated ecosystems, changes in vegetation and drought, and also intensive grazing by livestock are affecting the ability of native herbivores to obtain nutritious food. When these animals have physical stress and when they're at high densities, so say more congregated around more limited water sources, there are more opportunities for disease transmission among those animals. The disease transmission obviously affects wildlife, also can affect pets, and in some cases can affect people. So recreational opportunities are changing, and the populations that often people value for cultural reasons, for any number of reasons, are changing also. Bacterial, basically blue-green algae blooms are becoming more of a problem in a number of areas. And again, those are affecting the health of humans and the effects of animals, whether they are livestock or pets or wild animals. These blooms generally are facilitated by high heat, by nutrients, so including nutrients that people put in the water, or cow poop. I mean, any source of nutrients can increase the likelihood of blue-green algal blooms, and also low flow conditions. So all things that are expected to become more common as climate changes. These blooms can occur in either flowing or standing water. I think many of us tend to think of them as a standing water thing, but they can also occur in flowing water. This is a tangent, but I'm going to mention it because it came up in some of the discussions. Groundwater systems generally are thought to be somewhat more resilient to climate change than surface water systems. That said, they're more resilient if people are not appropriating groundwater for agricultural and other uses. And also, broad sweeping generalization, there is very little understanding of how groundwater systems, basically how the groundwater plumbing system works across the Intermountain West. There are also, as climate changes across sagebrush ecosystems, probably likely to see increases in some types of wildlife-human conflict. So animals are seeking water and food in areas with people, especially as there are drought conditions. Because they are coming into areas that are more human dominated, there can be more vehicle collisions, which obviously are a health risk to people as well as to the animals. More conflict with domestic animals, whether it's livestock or pets. And again, more potential for disease transmission. And that is disease transmission among wild animals, between wild animals and domestic animals, and among animals and people. I think I am close to end of time. So that's kind of a whirlwind, but I'll leave it there, and hopefully we have time for discussion now or perhaps in the future.